Hello students, hope you are doing good. Ready for the last part of the semester. And so for this week, we will be mainly looking at definite integrals and solving definite integrals. What do definite integrals actually mean? When we write an integral as a limit from a to b f of dx, then what does it actually mean? And looking at Riemann sums and also the use substitution for solving integrals, either definite or indefinite. So let me start today by actually looking at some of the integrals and definite integrals, the indefinite as well as definite integrals. So far you have seen the integrals of the type x squared minus 5x, let's say plus 7 d of x, right? And you saw these in the last exam, in the last week, when we calculated antiderivatives. So if I'm looking at this, then the antiderivative or the indefinite integral for this is x cubed by 3 using power rule for integrals, 5x squared by 2 plus 7x, and then we always have a c whenever we are talking about indefinite integrals. And similarly, we have, if I have 1 over x plus, let's say 2x, same thing dx, we know we can't apply power rule to 1 over x. The indefinite integral for 1 over x is ln x plus 2x squared over 2. 2's cancel plus a c. So the answer is ln x plus x squared plus c, right? So these are some of the examples of indefinite integrals, just the looking at the antiderivatives. Next, I'm going to talk about definite integral. Definite integral means when I limit limit it to the bounds. For example, I define a to b f of x dx, right? So this is a definite integral. Why is it called definite integral? Because this actually gives us a definite number, right? And what that definite number is, that's related somehow to area under the curve, or area under the function that we are looking at here. For example, here the function is f, right? So let me take, suppose my f is positive. Suppose this is the function f, and these are my bounds from a to, let's say, b. So this, if f is positive function, this is my origin here, 0, 0, this point right here. So if f is a positive function, then this integral right here that I have written, this definite integral represents area under this function, the area of this part right here. Okay. So that's why it's called a definite, and that area comes out to be a definite number. Okay, so by the fundamental theorem of calculus, or this actually can be written as a to b f of x dx, the definite integral can actually be written as f of b minus f of a. Now note here, these two f's are different. This is the f, the little f is the f given. The big F is the antiderivative of the little f, right? For example, this f here is x squared. The little f is x squared, then the big F is actually x cubed over 3. Okay, so these two are different, but what this fundamental theorem of calculus says, that if you have an antiderivative of a function, this f, big F, is the antiderivative of little f. So fundamental theorem, big F is actually the antiderivative of the little f. So if you can find the antiderivative of a function, then evaluating that antiderivative at the upper bound, which is the point b, minus evaluating it at the lower bound, which is the point a, will actually give you the area under that function f. Okay, or if I'm still thinking that f is positive. Okay, So let me take the, since I took the function x square here, so let me take the function x square here. Let's take x squared dx, and let's examine, or let's find the area of this from 0 to 2. Okay, so what I'm saying here is, this is my curve x square. I'm just taking on the right side, and from 0 to the point 2, which is 2 comma 4 here, y coordinate is 4, which I don't really need here. So I'm looking for this area right here from 0 to 2. Okay, so what my fundamental theorem of calculus says, that evaluate the antiderivative, which is nothing but x cube over 3, right? And then I'm just putting brackets here. I need to plug in the limits 0 to 2, 0 and 2, upper limit minus the lower limit. And we don't need c's here. In the definite integral, we don't write c's, as they do cancel, right? When I plug in 2, I put a c, and then when I plug in 0, I again put a c, and those two c's cancel. So no need to write c's when we are working with definite integrals. Okay, so let's plug in the value 2 here. I get 2 cube, which is 8 over 3, minus 0 cube, which is 0 over 3, so it's nothing but 8/3. So the area for this part right here is nothing but 8/3. Okay, let's move on to the next example. The next example is about, what if I have something like this, sine x dx, right? And let's look at from 0 to 2 pi. Okay, what is this integral? Okay, let's see. Sine function, you know, it looks like this. It's periodic. It finishes one cycle in 2 pi radians. So this is my 2 pi right here. This is 0. So I'm looking for some kind of area, but let's see if I use fundamental theorem of calculus, what do I get? What's the antiderivative of sine x? It's negative cosine x, right? And again, my limits are from 0 to 2 pi. I can put my negative outside. I can, because it's a constant, or -1, I can use it, I can leave it outside. And so plug in the upper limit, so -1 as it is. If I plug in cosine of 2 pi, so cosine of 2 pi minus cosine of 0, and both of these numbers are 1. So it's 1 minus 1. Outside you still have -1, which is 0, right? So in this particular scenario, if I am relating this definite integral to an area, what kind of area am I getting in this? It's 0. So basically what I'm getting is, I'm getting this area, which is positive, and since here the curve is under x-axis, I get a negative areas, and both those areas are equal. So if I have an A1 here and A2 here, you know, if the curve goes above x-axis, the same, it's a symmetric function, the same thing goes below, same amount goes below x-axis as well. But A2 is negative because it's below x-axis. So A1 and A2 actually cancels out, and you get area as 0 here. So so your area is 0 in this case, and this area is actually called the net area. So the definite integral, a to b f of x dx represents the net area between f and x-axis, It could be positive, it could be 0, it could be negative. Now if a function is just below x-axis, then it's negative. It could be 0 as we saw in the sine x case, and it could be positive as we saw in the x squared case, right? Now if I ask you, same thing, if I ask you find the total area, the question is find the total area bounded between x-axis and sine of x from 0 to 2 pi. Then what would you do? That this is not net area. This is, here we are talking about total area now. So if the question is find the total area bounded between x-axis and sine x from 0 to 2 pi, so basically if I look at the graph again, that's the graph of sine x. This is my a1, this is my a2. What it's asking, it is not asking about the net area, it's asking about the total area. So the total area is the sum of this plus the absolute value of the a2. So what you want to do is you want to divide. This is the point here where you want to divide. The first is 0 to pi sine x, right, dx, plus pi to 2 pi, which is your -1 sine x dx, right? But for this one, since it's negative, I'm asking about how much is the total area bounded. I'm going to put an absolute sign with the second one, which is a2, right? And also, you know, the sine function, it's symmetric. It's going as above x-axis, the area above x-axis, the same as the area below x-axis in this case. So what I can do is, I can actually use, instead of this, I can actually say this is same as twice of 0 to pi, the positive one, sine x dx, right? So twice of, let me do one thing. So, sorry, twice of 0 to pi sine x dx. And if I want to evaluate it, twice of 0 to pi sine of x dx. Again, the antiderivative is negative cosine x, so I can make it -2 cosine x, and the limits are 0 to pi. Okay, let's plug in the limits. It's -2, and cosine of pi, if I plug in, it's -1, minus cosine of 0, again it's -1. So that becomes -2 times -2, which is same as 4. So that area is 4. Actually 2 is above and 2 is below. Net area, it is 0 because both are the same. But for the total area, you have to make the -1 positive. So basically it's 4 in this case. The total area is 4 and the net area is actually 0. Okay, so that's the difference between the net area and the total area. When they ask for net area, you just evaluate the definite integral. When they ask for the total area, you break the function. For example, you break the function. For example, the function is something like this, like the sine x. You break it down here. This one is positive. This one, when you take, let's say this point is 4 and this point is 5 and this point is 0. So from 0 to 4, the function is positive. You calculate it like that. And from 4 to 5, the function is negative. So the integral will, you have to put the absolute sign with that 4 to 5 integral. Okay. So that's one of the major differences between the total area and the net area. I think mainly it's used in the applications of distance and displacement. If you excuse me, if you want to differentiate the net area and the total area in applications, the best application would be to see the displacement and the distance. Let's look at one of the functions. For example, if I have this velocity function of an object in motion, it's given by x squared, sorry, this is x, where actually x is time here, x squared minus 5x plus 6, and I'm looking at between the first 3 seconds how much distance has this vehicle or whatever that object in motion is, how much distance it has covered. What's the displacement and what's the total distance? Now the displacement is nothing but the net area. It could be 0, it could be negative because it's a vector, or it could be positive, right? But the total distance from starting point to the end point, it's never negative, never 0. It has covered, unless it was at rest. So the total distance is not 0. The total distance has to be a positive number, right? So for the displacement, what I would do is, for the displacement, it would be just 0 to 3. You don't care when it's positive, when it's negative. You just evaluate this dx. Okay, you look at the use fundamental theorem of calculus. You look at the antiderivative. 5x squared by 2 plus 6x, plug in the values, basically plug in 3, and I think you get 9/2, but please confirm. So that will be your displacement. So the displacement is coming out to be positive and it's 9.5. But let's look what's the total distance covered if an object moved with this velocity function between 0 and 3 seconds, right? So if I look at the graph, it's a parabola, right? X squared minus 5x plus 6. At 0, the point is 6, right? Oops. At 0, the point is 6. And then this is my function. Let me write down here. X squared minus 5x plus 6. You know it can be factored as x minus 2, x minus 3. So it crosses at 2 and 3, right? And I'm actually looking till 3 only, between 0 and 3 seconds. So it crosses at 2. So something like this is going on, right? Right? So it's positive until 2, and then at 2.5 you have the vertex or the minimum, right? 2x minus, if you take the derivative, it's 2x minus 5, set it equal to 0, it's 2.5 and whatever that y coordinate is. But it gets negative between 2 and 3, right? Now if I'm looking for the total area, it's 0 to 2, it's the same, f of x dx, plus when I do 2 to 3, I have to put the absolute value, which is f of x dx, right? So 0 to 2 is the same, and 2 to 3, you have to put absolute because it's under x-axis. Just same thing, evaluate the curve. The first thing is 0 to 2, x squared minus 5x plus 6 dx. Antiderivative is again x cubed by 3 minus 5x squared by 2 plus 6x. Plug in 0, so it's, sorry, plug in 2, so it's 8 over 3 minus 10 plus 12, which is same as 8 thirds plus 2, which is 14 thirds, right? And then this is the first part, and the second part is from 2 to 3, and that's the absolute, so it must be negative. 2 to 3, same thing, x squared minus 5x plus 6 dx, right? So same antiderivative, x cubed by 3 minus 5x squared by 2 plus 6x, right? And you plug in 2 and 3. I know the value at 3 is 9.5. That's what I calculated before. I know the value at 2, which I calculated in the previous slide, is 14 thirds, right? So this actually comes out to be negative 1/6. I take the absolute, so it's positive 1/6. Okay. So this is 1/6 and you have 14 thirds. So the total area or the total distance covered by the object with velocity function x squared minus 5x plus 6 between 0 to 3 seconds is 14 thirds plus, what was it? 1/6, right? 14 thirds plus 1/6. And which is same as 29 over 6, as against 9.5 as the displacement, right? So this is in whatever meters, whatever it's given, but that's the total distance covered. Okay, so that's the main difference between the total area and the net area. Very useful in applications like finding total distance or displacement in physics, and also in engineering. Okay, so probably in the next, that's it for this one. And for the next recording, I'm going to send Riemann sums and U substitution. So stay tuned, and I'm going to upload this recording right away so that you can look at it and see some of the problems. Okay, take care. Bye-bye.